Hi, my name's Rob Clark. I'm a consultant for Excitex Professional Services team. Today, for the next 20 minutes or so, we'll be looking at BIM coordination for real. We'll be using Autodesk software, specifically that found in the Autodesk Infrastructure Design Suite, but some of which you'll also find in the Building Design Suite. In addition to that, we'll also look at some of the online BIM 360 tools, plus an additional Autodesk tool, which I'll talk to you about later on. The purpose of this video really is two reasons. One is to demonstrate the BIM coordination workflow, which is absolutely essential to effective design, which I'll talk about in a moment. But the other one as well is to talk about using BIM to use the right tool for the job. I'm a big believer that, like in the real world, when we're constructing something, we very rarely actually use a single tool for the job. So when we're talking about virtual design in building information modeling, we shouldn't try and push it all into one box and then wonder why it doesn't do everything that we want it to do. In other words, if you've got access to a circular saw, don't use a knife to cut a block of wood. The other reason for this video is obviously to demonstrate BIM coordination. If we're designing something, we need our models to be coordinated effectively to make better decisions. That be it building models, but also the civils, infrastructure, utility models as well. They also need to be coordinated in as well as far as possible. And hopefully this video demonstrates it's not too difficult. But going beyond design, we're increasingly talking about these models being deliverables themselves, and those deliverables being used in construction management. You may also have client requirements as well, like asset registers, which also federated data is needed for. So hopefully this video will be useful to you on multiple levels, and hopefully you'll pick up a few tips and tricks along the way as well. So the first thing to do is create a map of our site, fairly obviously. So we could use something like ordnancesurvey.co.uk, and we could use the Open Data website, where we can download OS vector map data in shapefile format completely free of charge. So in this case we're going to use district SJ, which is a district just in North Wales. That's just going to download in a zip format. Now we've also got services like Get Mapping. There's various services out there like this, and we can use get street level maps in here just by postcode if we want to. Now when we actually get these, we need to just choose the size of the map that we want to get, mainly because it usually costs more the bigger the map you get. We can download that in a fully coordinated AutoCAD format. So here we are in Autodesk Map 3D, and I'm just going to create a new database connection and add that shapefile data to it. Very, very easy to do. Just connect the data, and what it does is Map 3D recognizes this GIS data and recognizes the layers within it. So I can go and grab the road layers, for example, and also the land. But you can see there are a number of other layers that I can pick up if I want to as well. Because it's fully layered information, I can go and edit the styles here, and I could go change it to a green background, for example, whatever I needed to do. However I need it to make it look is very easy in something like Autodesk Map 3D, because instead of using drawn information, it's element-based information. So I'm using the XREF tool now just to bring in those Get Mapping street level maps, and you can see because it was already coordinated, it lands right over the top of that GIS data. If I use now something like my polyline tool just to mark out my building location, I could use my ID tool in AutoCAD now just to find that location. Fairly simple process. The next thing I want to do is I want to create a 3D surface of my survey of my local site. So using something like Autodesk Civil 3D, I will use the points tool here to create my Kogo points. I can create them manually and various other methods that you'll find in here, but the more commonly used one is to get them directly from the site equipment. And I'll go and grab those in and pull these in as well. And you can see that that puts the points directly in the coordinated location straight from the equipment. And now if I want to, I can go up to my sites, my surfaces here, and create a new surface which I'll entitle rather imaginatively existing surface. One of the things I'll need to do here is I'll need to choose the surface style. So I won't make it out of triangles, but I'll use contours. So this is 0.1, 0.5 meters minor and major contours. We need to define the surface because it's not there yet, and we can define that surface by a number of ways: polylines, break lines, contours, point files, or we can make them out of point groups, such as the all point group, which brings in every single point. Now on this site we have some building information models produced in Autodesk Revit, and one of the things we need to do is make sure that those are coordinated with our site, obviously. So if I come into this model, which is fairly typical, and draw a spot coordinate, I'll find that when I put a spot coordinate on it, it's nonsense. And that's mainly because when you start modelling in Revit, not a lot of people give thought to the coordination at the beginning, and it's not really essential that you have to either. You can see it's not coordinated to the true north. So what I'm going to do is actually create a site coordination model, and I'm actually going to do that by creating it just using the architectural template that comes with Revit. There's a site view in here, which simply means that it can see everything but in the vertical space. If I go to the visual graphics screen, which is VG, keyboard shortcut, I can turn off this properties base point, and I'm just left with this triangle, which is the survey point. Now what I'm going to do here is I'm going to bring in that map that I just created in Map and Civil 3D, and I'm going to import my units, make sure they're set to meter because it's a meters, and I'm going to use center to center as the option, which surprises people because a lot of people expect you to use origin. Revit's slightly different. The basic principle is think about moving the world underneath the model, not moving the model to the world. And how that works is if I now acquire these coordinates, the model is going to stay exactly where it is, but as I acquire the coordinates, that triangle is going to move to what is the relative origin point. So the map is stayed dead in the center of the file. It's the origin that's moved. In other words, the world has moved under the model, not the other way around. Now if I come in, I can see my building pads, which are marked out in Map 3D, and I can link in my building models. I do this just under a standard linking arrangement using the manual insertion point, which puts it on the cursor. I'll just take a few seconds now using my modification tools to accurately position that in place, and what I can do next is use my point cloud tool to reference in a point cloud that I've got, and because that point cloud is geo-referenced, when I use shared coordinates, which is the first time we use that shared coordinate system, you'll see that that point cloud lands in the right place, proving that our coordination is now starting to take effect. So one of the things I'm going to do here is I need to transmit that coordinate system from this model into the individual building models. So I'm going to click on the model, and in the instance properties here I get this option to publish the shared coordinate system from this site coordination model into the actual linked file. A quite unique ability within the Revit software. So now, just to prove that that's worked, if I go into the building information modeling file, remembering to save the coordinate system as I exit this file, and I'll save it as a site coordination model. If I go into my actual building file, the one that we just went into just a moment ago, and I'll take a look at that coordinate, and you'll notice that coordinate is now correct, and also that my model is now orientated correctly to the true north, and I can switch it back to Project North. So it's very simple to coordinate a shared coordinate system within the Revit software. The key is really creating that site coordination model. You can set elevation in a couple of ways. You could publish the coordinate in the actual respective models, or in here, if I go in and reference in my topographical surface into my site coordination model, the one that we produce in Civil 3D, and create a new topo surface within Revit using the import tools. The nice thing about Civil 3D is it layers everything quite clearly for us, and I can go and just grab those minor and major contours that I had before. And basically what Revit will do now is it will project our surface over the top of that contour, and you can see now that that is now working properly. If I come back into the actually normal building model and go to, say, the datum for the ground floor, which is in the wrong place at the moment, if I go to my coordinates tool here and publish my coordinates, I can set my level in the right place, which I found using Civil 3D earlier on. If I come back to my site coordination model, it is now in the right place. One of the advantages of doing this, if I just use something like a reference plane in my Revit tool, I can actually go ahead and draw something like a section through the model, thus being able to see my building models in the Revit platform with respect in orientation with my actual site surface. So now we need to coordinate in other models as well. So where we might get a model that comes from somebody else who hasn't coordinated, the easiest way to do that is frankly to open up their model, referencing your model which is properly coordinated, and move your model into the correct space, perhaps using the grid lines as the datum. So if you are in the design lead role and the people sending you the models haven't coordinated it, you could use this method where you link in your model over the top of theirs and just acquire the coordinate system from your model, which will basically coordinate both the actual coordinates and the north orientation as well. So let's have a look at model federation, which is one of the workflows which is enabled via this coordination. So if I use the Autodesk Navisworks Manage software here, I can now simply link in B1 and B2 models, as well as the map created in my Civil 3D platform, as well as some utilities, site utilities that we produced in the Autodesk Civil 3D platform as well. Because they've already been coordinated, providing the model reader settings are correct in terms of units and coordination, they'll all land in exactly the right place. This gives us the advantage of doing basic interference checking between files. So I'm just going to create a new test here in the Navisworks platform, and what I'm testing is the utilities versus the foundation. Utilities coming from Civil 3D, foundations coming from Revit. I'm just going to do a comparison between the two, and I'm looking for a clearance, because obviously one of the things with foundations is you want to ensure that the utilities are outside that area of influence. I'm just going to set my rules, including making sure that I'm not checking for issues within the same file, and I'll just run that check. Navisworks very cleanly and easily shows me those clashes, and it allows me to visualize them very quickly. So as you can see, I've got these 6 clashes that I need to deal with. I'm going to write a report out, which can come through in the HTML format, but also one of the other nice little interoperable workflows that you get with the Navisworks platform is if I select my element like this, which I know now is causing a clash, if I right click, I have this option called switchback. And switchback, if I use it, if it's on the same platform as my Revit platform, I can now switch back to Revit, and I'll discover that it's created a new view called Navisworks Switchback, and that foundation is already selected. I could resolve the clash, and in my typical way of resolving these things, the easiest way to resolve a clash is to delete the element in the first place. Perhaps not the most practical solution, but certainly a solution. And I can go and edit these foundations appropriately. Because Navisworks is one big model federator, it maintains the live links and so forth. Providing I save that file, if I'm working remotely, I'll just send that across to them. But what I'm able to do now is just refresh the links. Navisworks will detect that there's been a change and reload that link in. If I rerun the test, I will find that those 2 clashes that were being caused by that one foundation have now been automatically listed as resolved. If you do need to do it, you can also send the element IDs across in the report, which people can also use to find it. Now, one of the nice tools that Autodesk have released to us is Glue 360, which is basically Navisworks on the cloud. So what I'm able to do as a user is actually, because I've got these coordinated models now, is actually upload those onto the Autodesk 360 servers via the Glue add-in that we've got. And it takes a few seconds, but it goes up. You need a relatively fast connection, but it's not too bad. I'll do that for both the structure and the architecture, making sure that I use my shared coordinate system to glue those up. Now, if we look at the Glue platform, in here I'm able to do most of the things that I could do within the Navisworks platform, but this time I'm able to do it online, which means I can use any available connected Windows machine. If I was to go and choose my structural and architectural models, I can go and merge them or federate them like you do when you append two models together in the Navisworks platform. Again, very quick to do. You're using Autodesk service to do this, so it's very, very fast and very, very slick. I can move around the model, orbit it, navigate it very, very easily, hide things away, and so forth as quickly as I need to. So in here, if I wanted to do some basic clash reporting, again, like the main model, if I do something like walls versus framing, it works very, very similarly to the Navisworks tool, and I can go ahead and find these clashes. I run the clash report, and it's going to find the individual clashes, including this one here. Because it's online, though, the idea here is to collaborate amongst the team and assign responsibilities. So I'm going to assign the responsibility here and send that across to my colleague. And my colleague is using, again, the Autodesk Revit software. They may not be on the same system as me, but they can open up the clash report from the tool here and view that particular clash that's been assigned to them. And Navisworks will go and, Revit will go and assign that particular clash, allow us to see that particular clash. The other things you can do in here which are worth noting is you can do basic marking up and things like that, and add in views, which can be again conveyed to anybody within the team. So you can create as many views as you want, and you can also do some basic marking up as well. So your markup tools are just here, and we can do some basic marking up. And again, a bit like the Autodesk Navis software, the Glue software is quite basic when it comes to marking up, but definitely effective at what it does. And if we've got something like an iPad or something like that, we can quite easily go and use the iPad's tools, the BIM 360 Glue application that you can get from that, to go and view that model online. You do need to have a Wi-Fi connection or an internet connection at the time that you open it, but it does crash it after that point, so you don't need to maintain that internet connection to continue to view the model. And you can see it's again very easy, quite easy to use. We can go in here and we can see various views and so forth quite easily. It's easy to navigate, very simple interface. So you can imagine being able to be on the train or be able to be on a flight someplace and being able to still participate in that design process if need be. You can also see your markups, the ones that you made within the actual Glue software, so you can have a collaborative workflow. So one of the other things you might need to do is you might be staking out in the field, you might be working with colleagues on site, and Autodesk have actually just introduced this new tool called Autodesk Point Layout. It's purchasable extra, but it might be worthwhile if you're working with people on site. So it introduces a number of tools for laying out points, and you can see them on this new ribbon that gets added into the Revit software. If I go and have a look at what some of this does, if I go and click on one of the walls, for example, I'm then able to use the points tools to actually set out points, a bit like the Kogo points if you like, that actually mark out positions on that wall. So if I go to the wall points here, I can stake out some points, and I can say that I want to start at point number 0, and they're staking out there for the current phase, that I want to use the current selection, and I want them to be set at a certain distance from one another, in this case 100 millimeters. I want to choose the location on the walls as well, and if I press on OK here, you'll see that it adds these points in. I'll just zoom in a little bit here, and you can see if I highlight them for you that those points are now located as objects, and you can see the properties associated with them. You'd carry on and do the whole thing for the new extension that we're putting on this building, and then I can export these points out, and I can export them out to a DXF and a CSV file. You can see here as well that I'm also able to attach them to issues for use in Autodesk 360 Field as well, BIM 360 Field. So I'm just going to set up the settings here and choose the option to grab the DXF file and choose what coordinate system I want, which is obviously the shared coordinate system. So again, it's essential that your coordination process has happened ahead of this. And then once I export that out, it will become available to me for use in site equipment. So one of the things you can do if you work with certain providers of site equipment is you'll be able to send this file that has been created over something like an internet connection to people that are actually working in the field. If they've got the right sort of surveying equipment, they'll be able to download that into their particular equipment and be able to find those same locations on site. Equally as well, there is an import option, so if they need to mark out any positions on site which they need the designers or the construction management team to understand within the Revit software, they're also able to do that as a backward workflow as well. So I hope you found this video very useful, and I hope it's demonstrated to you some of the power of the design suites. Clearly we haven't used every piece of software within the design suites. What I really wanted to demonstrate more than anything was that you can move information through these suites really effectively, and it's not really that difficult. There are a number of other workflows we could have demonstrated today, such as for example using Autodesk Recap to develop models from clouds and actually bringing those in a coordinated manner also. So there's really endless workflows that you can explore using the Autodesk design suites. I hope this video has been useful, and do get in touch with us if you have any questions.